Okay, then I think let's start. Oh, no video in display. Oh, you are only four students, then why not at the front? Why you are sitting behind? Come forward, huh? What? What you are saying? Why? My leg is. You are not a disabled person, huh? So this is only you are talking, you are giving reason without any solid reason, okay? You are just talking that I cannot move. Anyhow, it is only 40-50 minutes, not more than that. It is 1 hour class, huh? Okay. So maybe your muscles were frozen or in a silent state, you can say, huh? You can call it jamid or something like that. So that is not an issue. If you will move, everything will be okay, huh? Okay, go there at the top. Okay, this is the topic actually. Previously, we saw what is correlation, and I think we have done practice with these all these four or five different things. So now the topic is about skewness of the data. So review skew of attribute distribution. So normally skew means that your data is positioning or aligning on one side, okay? Either on the left side, either on the right side, or something like that. Normally, the literal meaning of this skew. And you can better view this skew only through visualization, okay? But but you can analyze this skew only through visualization. But here we are in the topic of understanding different things through stats. So that's why now we are going to see the skewness of the attributes, of the variables, of the column headings, which are so those attribute, how the data of those attributes are distributed in the data set. We want to see their skewness. Either they aligned on the left side or right side or whatever. Why? Because normally our data set should be according to the normal curve, okay? Gaussian distribution. If our data set is like that, then it is good, okay? But something, skewness is something like that, okay? Sometime like here, or maybe if you have something here, or sometime you have here. But I don't want to talk because this is visualization. I will talk this in visualization when this topic will come again. So here we want to see the skewness through numbers. So the first thing is, if the skewness is there in your data, then you need to correct it. You need to correct it. Why? Because we want our model to be in a good and accurate shape, okay? So how we have many algorithms, we have many machine learning algorithms, and all the algorithm normally assumes by default that our data is in normal Gaussian distribution form, or according to the normal bell curved data. Okay, as I explained, normal bell curve data means this. So all this is not exact shape, but so all our machine learning algorithm so assumes that our data is already in this normal curve form. Okay, so this is some which is the other name for it is the Gaussian distribution. So our machine learning algorithms normally assume that our data is distributed according to this Gaussian distribution, which is normal curve. And if it is not, then it is a kind of a problem, and you have to remove that problem. So this skewness, this skewness can be positive or negative. Okay, this skewness can be positive or negative or zero. Zero is something here. Okay, sorry, this line is not straight. So now it is, so this is zero. And then this curve can be on the left side or the right side or whatever. And then you can call it positive or negative. So if the value of your data is close to zero, then it is close to zero. If it is zero, no skewness. And if it is close to zero, then it means there is some skewness, some less amount of skewness. And if it is far from the zero, then it is quite much value of the skewness. So here is the code. When you normally came in the class, please don't say salam. Just go there and sit, okay? Because when you talk, it creates disturbance, okay? Even salam is not needed, okay? Okay, so now, so this is a short code to see the skewness of your data in numbers. So this is the same from pandas import read CSV. So we are just, this is the path of, this is the data set we are going to consider. Here we are creating headings for that. And then we are reading that file, which we are storing in this data object. And then print data.skew. So you only have to write this. This data is the name of the object in which you have all the data of your data set. And then you have to write skew. And when you will use it with the print, this is the output. And here you can see the value of all the variable. This is one attribute and it has value this 0.90, which is a little far from the zero value, huh? Which means this is a positive skew. This is not close to zero, okay? This is positive skew. And this plus is 0.17. So this is positive but close to zero. So you can see that if it is more than 5, then you can say it is something positive skew. And if it is minus something more than -5, minus 0.5, then it is something negative skewness. Huh? So here, another attribute with value -1.84. So it is -1.84. So now definitely it is a little far from the zero, huh? Going in the negative side. So it is negative skew. This is 0.11, close to zero, huh? So here you can see, okay, this is bearable. This data is okay. The value of this column, whatever the data you have here, that is okay. But this test, it has 2.27, more than 0.5. So it is positive skew, you can say. Similarly for others. And you know the D type here, it is giving you the data type of these columns, nothing else. So this is called skewness. And now we are moving towards the visualization part for data understanding. How we can understand the data with visualization. Now through stats we have other things, but these are just samples, okay? These 7 things that you have seen it is just a sample. and we can do many things. Now, now through visualization, how we can understand the data through visualization? So some people can understand the data through numbers, and some people can understand the data through visualization. So visualization will definitely help us to understand the data in data sets, nothing else. So through visualization, we will see that what is the situation of our data. And through visualization, we can see what are the different relationships or correlations. It's the same thing. So what are the different relationship between different column headings, between different features, between different attributes? Same name, huh? Attributes, column heading, variables. What are the others? Huh? Features. So the same meaning, okay? So how, so we can also see the different relationship between different features or attributes. So normally now data visualization techniques are divided into two categories: univariate plots. Plots mean the things that you can plot in a visual form, okay? Like a chart, like a graph, huh? Univariate plots, multivariate plots. So univariate means where you are plotting one attribute, one variable, huh? And multivariate plot where you are plotting more than one variables or features together. Okay. So then univariate plotting has further three categories: histogram, density plots, box plots. We will see these categories one by one. And then multivariate has correlation matrix plots, scatter matrix plots. We will see these things one by one, starting with the univariate plots. Uni means single, huh? Variate is from the word variable, you can understand. So it will show single variable. So visualization about the single variable. Or you can say understanding the variable or attributes independently, without a relation with the other attribute, independently. So no, so this is a technique, and through this technique we can understand the feature or attribute or anything, single attribute, independently, without a correlation to any other variable. So that's why we are in univariate category. And there are some techniques in Python which are available. First one is histogram. What is histogram? Histogram will do what? It will show you the data like bins. This is a bin, huh? One column is a bin, okay? So the one column that you are seeing in these visualization, that is called bin. Here, bin is a sophisticated word. Otherwise, you can use the word column. But these bins can be in a different shape, okay? Not always columns. So histogram will do what? It will group the data in visual bins. It will show you the bars. And this histogram is also, this is the faster way to get an idea about the distribution of each feature, each attribute, how your data is distributed in the data set. This is the fastest way. Visualization is fastest way than the numbers, huh? Than the numbers. So that's why, okay. What are the different characteristics of histograms? It will provide us the count. It will provide, for example, here, if it is a data set, like here, pregnancy, but this is not a count, okay? Suppose if you have 6 here, then this 6 will represent that this person has pregnancy, this woman has pregnancy 6 times. So it is giving us a count, okay? It is giving us what? Count. So histogram will provide us count of observation in each column or in each bin. And through this histogram, we can also see the distribution of the data, that either your data is in Gaussian form, this is Gaussian form, normal curve, huh? Or skewed, so this is positively skewed, huh? And they are exponential, so this is also skewed. If I will move, make it, so this is what normal distribution. Now my pen will not work here, okay? And this is what right or positively skewed, negatively skewed. And here, if you have something like that, this is called uniform distribution. Every value has the same, huh? Uniform. This is again normal curve. And this is what? You have two normal curve, which means you have two by model. Maybe you have data set from two different things. Okay. Your data is not symmetric here, okay? Symmetric bimodal distribution means you have two distributions similar in shape. So that's why the word is symmetric, which is an evidence that your data is something repeated, or your data is taken from two different things. So sometimes you will have the same shape and sometimes you will have a different shape. This is non-symmetric bimodal distribution. Bimodal. This is not good, okay? Only this thing is a good thing. Normal distribution. The rest, the other things are not good things, okay? Only these, anyhow. So this is the purpose of the histogram, why we normally see the histograms for our data. How you can do that? Again, we will use the pandas date frame. And for plotting, we will use the matplot library, okay? We will use now another library. Along with the pandas, we will use another library that is called matplot library. How you can, so now we are writing from matplot library, import pyplot, and we are importing pyplot from it. This is the pandas, you already know. From pandas, import read.csv, okay. Here, okay, Paima Indian diabetes data set, creating headings, reading that database, putting it in this object data, and then when the data is there in this object, now data.hist. Data.hist. You just have to write data.hist for histogram. Okay, then histogram is ready, but it is not plotted yet. How you can plot? Pyplot.show, this pyplot, which is a module available in this matplot library. Huh? So through this, now this is a kind of object of that matplot library. So pyplot.show, when you will use it, it will display something like that. It will display something like that about the Paima Indian diabetes data set. So have a look over here. Now I cannot use the pen. Okay. So this is what? This is skewness, huh? So this is rightly skewed or positively skewed. You can also call it linear regression, huh? Going, sorry, you can call it exponential, okay? In reverse direction, from high to low. Speedily, quickly, exponential. And this is for the class. And you know that this class variable has only 0 and 1 value, so that's why only 2 bars. And this is for the mass. It is not exactly like a normal curve, but it is in the middle and the shape is like that. Huh? So here, So here I can say that this age does not have appropriate values. Okay. Here distribution is not okay. But here for mass, the distribution is almost okay because it is close to the Gaussian distribution, huh? Normal curve. This is again the skewness distribution is not okay. This is again like normal curve, but your curve is a little bit on the right hand side from the middle. But you can say it is here the values are better than this and that, okay? And here again the values are disturbed, even it is not an exponential, even it is not a exponential, but it is, you can say it is a kind of a skew. It is again to normal curve, but your data is a little bit on the right hand side. So, but you can say it is okay. It is not that much disturbed. This data is not that much disturbed. So this is disturbed, this is disturbed. So through visualization, you can understand something like that. And this is mentioned here, age, paddy, and test, exponential distribution. What is age? This is age. This is paddy. And what is test? Okay. This is age, this is paddy, and this is test. And here we are saying that this is disturbed due to that skewness. And mass and plus, Gaussian distribution. Okay, let's see that. This is mass and this is plus. So this is Gaussian distribution. You can also say something like that. These three are almost Gaussian distribution. Okay. This is not something final. Okay. This is just an idea. Now, density plots. By the way, this is available. This histogram is available here. If you will go into this histo, that pi that would be available. And if I will run it, you can change the database, huh? Here the database is like that. Sorry. The name is histo. So this is the output. You can make it big. You can make the size bigger or smaller as per your need. So this is how that 4-line code is giving you the output. Okay. Now density plots. So this density plot is again like histogram, but now histogram is a kind of a field diagram, huh? Field visualization. But this here we have something, a line or a curve is drawn here. And now we can also call them with another name, abstracted histograms. And this is the code for that. So again, matplot import pyplot, that is same, like in previous program. Panda same, path same, heading same. And here we are reading that PIMA Indian diabetes data set. This data is the object, and then we are plotting data.plot. And then here we can say the first thing is kind. What kind of plotting you want? And then a kind is equal to, within single quote, you are writing density. Here you can write histo also, okay? If you will write histo, it will give you the histo. And you can write other. There are 8, 9 different diagrams that you can write the name there. Okay. You can just copy this command and paste it in the browser. It will go into the documentation of pandas, and in the pandas you can see how many different diagrams through this plot you can plot. Okay, it will show you. So you can display bar charts or even line charts or different charts, huh? You can display. So kind is density, and you are saying subplots true, which means plotting all plots. So this is subplot. This is subplotting. Okay, subplots true means all. Show some plot for attribute 1, then show some plot for attribute 2, show some plot for attribute 3, and so on. This is what it means. And layout 3 3, so you can see 3 rows 3, yeah, 3 rows 3 columns, huh? And share x is equal to false, and share x is equal to false. There are two options: share x is equal to false, share y is equal to false. It means that you are not sharing the x axis values within the attributes, okay, between them. So normally you have to put these false, and then it will show you something like that. And here from this density plot you can also understand the things like that. So here your data, you have the skew, huh? Shape is like a skew. This shape is like a normal curve, huh? Here it is like a normal curve, but this is not normal curve, huh? Data is disturbed. Here you have the skew. It is like a normal curve. Here you have the skew. Here you have the skew. Here, this is not a normal. You have two bell curves, huh? So, so through these visualization, then you can get an idea that which attribute is distribution of attribute is okay, and which attribute does not have a correct distribution of data in it. And now, after that, box and whisker plots. So through this technique, or through this box and whisker, we can also see the distribution of the data. All the techniques that we have, we can see the distribution of the data. That is the general word you can say about all techniques, huh? Then each technique has its own something, a kind of, you can say, specialty. So through this technique, what we can do, we can summarize the distribution of each attribute. Each attribute. It will show you the box and whisker plot for every attribute, for every column heading. What it will do, it will draw a line in the middle value, or you can say it will show you the median. So this is a box, and this is the mid center line, this is the midline. This midline will show you the median of that attribute, okay, and that attribute will have values, huh? So this center line will show you the median of that attribute, and then draws a box around 25% and 27%. So this lower quartile, so this line is depicting first from here, from minimum to here. So this is depicting 25% of 25% of values. And then you have upper quartile, which is we are calling Q3, and it is representing 75% of the values. And this whisker, and then these are called whiskers. So this is the box, and these are called the whiskers. And these whiskers will give you the idea that your data is, how much your data is spread, because this will show you the minimum value of your data, This will show you the maximum value of your data. And the box is in between. This line is 25%, this line is 75, this is the median. You can say 50%. Huh? And then you will have dots outside the whiskers. Huh? Maybe you will have some dots here, some dots here. And if you will have some dots on these positions, dots mean something like that. Huh? If you will have something like that, then these dots would be called what? Outliers. Anomalies. Huh? Some value which is uneven, rare event. Huh? Outliers. Now the term is outliers. And this whole range, we are calling it interquartile range, IQR. Anyhow, leave it and move on to this. So matplot, same, pandas framed, database same, heading same, reading same. And then we are data.plot. We are plotting what? Kind is equal to, not density, box. If you want to plot these box and whisker plots, you have to write box. Subplots true, layout 3, share X and share Y false. Okay. The same, huh? The same like previous. Only thing is, change is kind is equal to box. And when you will run it, you will see something like that. What is? You will see something like that. And now it is showing, giving you the idea that the attribute is preg for pregnancy data. And the values are from 0 to 15. So there is, and this is the box. This is the minimum whisker. This is the maximum. This line, green line, is giving you the median, which is, maybe it is 3, huh? Maybe it is 3. So the median of this data is that different women's, you can say, at least 3, average is what? 3 times pregnant, huh? And then 25%, what? Maybe here 25% is achieving a here at maybe 1, and it is 70% is reaching at 5. And then you have these dots. These dots means you have some exceptional cases which has almost 15 time pregnancy, huh? 16 time pregnancy or something like that. But your data is starting from 0 to 15. And this is the spread of your data. And here, okay, here the value is starting from 0 to 15. And maximally you are going up to 15, but your data is around between 1 to 9. Values are normal, huh? You can see. Here, look over here. For data is going for plus 0 to 200. The median is what? The median is around after 100, maybe 120. And then your values are from a minor less. 25 is starting from maybe from 80, and then it is going up to maybe 140 or something like that. And the spread is from maybe from 40 to 200. Okay, no issue. The data is almost in the middle of these values, huh? You can say it is not something. It is not something only if your values are starting from 0 to 200, and if your all box whisker is from 0 to 50 and no anything left, then you can say your data has lower values, huh? According to the scale. Here the scale is from 0 to 100. Your data is mostly between, you can say, 60 to 70, and there are some outliers. That is also your data is in the middle position on this scale from 0 to 100. Look at this. This is something different. From 0 to 100, the range of data is 0 to 100. One outlier at 100, huh? And then mostly data is between, you can say, 0 to 25. So your data is aligned towards lower values. So your data is aligned towards lower values. So here some balance is needed. Huh? Some balancing is needed. Similarly, here from 0 to 800, mostly data is here on the lower values. And then you have outliers. Here balancing is needed. Here balancing is needed. Here from 0 to 60, your data is in the middle. Okay, some outliers, no need. Here from 0 to 2, the values are from 0 to 2, not 0 to 200. Okay. So that's why if it is in 0 to 1, okay, no issue. Because you have only 2, 3 values, not more than that. And here from 20 to 60, your data is in the beginning. So here you can say a little bit balancing is needed. And here classes, you have only two values, 0 and 1. So that's why like that. That's why you have the box and the whiskers at the same position. Minimum whisker, maximum whisker, and the box. No median. Because this column has values only 0 or 1. Now, let's have an idea. Age, test, skin, they are skewed toward the smaller values. They are aligned toward the smaller value. What are age, test, and skin? Let's see it again. Age, test, and skin. This is age. Okay, this is, yes, it is skewed. It is aligned towards lower values because the range is almost 100, huh? Almost 100, and mostly data is on the lower part. Age, test is very much clear, 0 to 800, and mostly data is maybe from 0 to 100, huh? Age, test, and skin. This is skin, and I already talked about this. 0 to 100, and your data is already in the lower value. So these are skewed, or you can simply say they are aligned towards lower value. And here balancing is needed. Here some correction is needed. Okay. Now the second category is multivariate plots. How we can plot multiple variables, multiple attributes, huh? Multiple attributes together. So it means that if we are going to consider multiple attributes, it means now we are going to show the relationship between multiple attributes. Then there are some techniques how we can go. So the first one is, and if you go to that previous technique, multivariate plots, two techniques, correlation matrix plots, scatter matrix plots. And here we are going towards the first one. Correlation matrix plots. Through this correlation matrix plots, the first thing is, it is for the multiple variables. It is to show multiple relationship or correlations between the multiple variables. This is a technique to show the correlation between multiple variables. This is the one thing. So then how we can show them? So we will use the core function which is available in pandas, and we will use the pie plot. And through this correlation matrix, we can identify that which variable has a strong correlation with other variable, or which variable has a low or a weak correlation with the other variable. So let's see that. So this is the source code. This is same. Pandas same, and we are importing numpy, another library. So if it is not available in your Python, you have to download it, like you have downloaded pandas yesterday, huh? So you have to download and you have to pip install, then you have to write pip install matplotlib, pip install numpy, then it will be installed. This is the path of the database, headings of the database. We are reading and putting it in the data. And then here we are calculating data.core. So in the data we have the data set, and now data.core, now correlations will be calculated and it will be stored in this variable correlation. This is the variable. And now you have to plot. Now you have to plot something like that. And for plotting, this whole thing is for plotting. And here, first we are saying we are using this pyplot. We because it is matplot library, we are using it, and we are saying pyplot.figure. So we are setting a figure. So we are setting a space for the figure, and then that space is now fixed in this variable fig. And then fig.add subplot. So when you have fixed this fig, so this area is, you can say, this area is now allocated. Memory is allocated. And then fig.add subplot. So add a subplot in this figure with these values. What is the meaning of that? Here first means one row. Second one means one column. One row, one column. And then the last one means first subplot. First subplot. So in this figure, so some area is now divided, first row, first column, and the first subplot. So if you have not shown, normally in the figure, you normally write first, okay, that you will have 12 subplots in that figure, okay? Normally you mention, but here it is not mentioned. But here it is not mentioned. So if it is not mentioned, then we are fixing some plot, one row, one column, and first subplot. And we are fixing this area and we are calling it with AX. So we are fixing this area, you can say. First row, first column, we are fixing this area for this subplot. Area. And then we are using ax.matShow. So this is again the module that we are using. And then this matShow, this is a method which is taking your correlations, and then vertical minimum value is -1, maximum value is 1. And it will show the matrix with these values with the CACs. And it will show, it doesn't mean that it will show physically. It will calculate something and we are storing it in CACs. And here in the next statement, fig.color bar, and we are passing this CACs into it. So this color bar, this is the color bar, which is displayed on the right hand side. This is the color bar in the figure now. We are fixing this color bar with this CACs here, with the minimum value -1, with the maximum value, here it is, here the maximum value is 1, minimum is -1, due to these values. But here fig.color bar CACs, this is the statement for this color bar. And now we are focusing on this area. Numpy, we are using this numpy. We are drawing these cells, okay? Numpy, this is the library. And in this library, some method arrange is available. And now we are giving some value to it, 0, 9, 1. What is the meaning? Start from 0 and stop at 9 and step Step is what? 1. You are giving these values to this method. It is acting, this is not a list, okay? This is the method. It will start creating the cells from 0, then 1, then 2, then 3, then 4, then 5, 6, 7, 8. And before 9, it will stop. So from 0 to 8, it has 9 cells, okay? It will go from 0, 1, 2, 3, 4, 5, 6, 7, 8, and at 9 it will stop, because 0 is the start and 9 is the stop. And here in this method, you don't have to go into the design of this method, you have to use this method, huh? But how this method work? Starting value, ending value, and start it will stop before the ending value. And the step, what is one increment, you can say, huh? And then it will create something. It will start from 0, it will stop at 9, and the step is 1. It will do what? It will create an array of 9 cells, stop not included. I have given this instruction for your understanding with the comment here. This is the comment. It will create an array and it will store that array in ticks. So ticks means these ticks, that minor ticks you are seeing here, huh? Are you seeing? Okay, these minor ticks. So now this AX is what? AX is the area that you already fixed. I already mentioned that this is the area you are fixing in the first row, first column of this, in this whole diagram, huh? You are calling it first row, first column, this whole thing. And then here you are doing what? You are taking this object now, AX dot set X ticks with the ticks. So the x-axis, set it with the ticks. So okay, then in the diagram, these ticks will be displayed. Okay, these ticks will be displayed here and also here. These will be displayed and counted. It is 9. And then AX dot set Y ticks, and this ticks which are 9, it is going into it, and it is creating what? Setting 9 Y cells. So it is, you can say it is setting these ticks, which means setting these also cells, 9 cells, or you can say these ticks, whatever you want to say for understanding. It is creating 9 cells here, 9 cells here. And then AX dot set X tick labels and the names. These headings you are passing into it as a label, and X on labels on the x-axis, and similarly on the y-axis will be set by these two commands. And then pipeplot.show. Now you are showing the plot. Now correlations is already calculated, which is given here in this mat show, okay, with the minus and positive values. And you are displaying color bar with these values, and also core values are calculated. So pipeplot.show, and then it is showing you this thing. It is showing you this thing. And this means, and here, pregnancy, with the pregnancy, it means positive correlation. When it is 1, it is positive high correlation. When it is 0, no correlation. When it is -1, negative correlation. Huh? This is what this color bar is giving you the information. Blue means negative, yellow means positive, and here it is a mixture. This is 0. So this is high correlation. And here this is a little bit yellow, these two. So it means it has some kind of a positive correlation, huh? And similarly, this one yellowish, these are yellowish. Okay, so these yellowish has a positive correlation, huh? And then these green ones, even these green ones, mostly green ones also has the positive correlation. We don't have exactly this bluish color in this diagram, huh? So in short, I can say mostly I have the positive correlation between the attributes. Mostly I have the positive. How I can say what is the relation between plas and skin? This cell is giving me that idea. What is the correlation between mass and class? This cell is giving me an idea. Huh? This is what through visualization you can understand. And in the next, we will see it, inshallah, in the next lecture.